Alright, picking up right where we left off. An airplane. So here's our airplane. Look how fast it's zooming. There's fire coming out of the engines. This airplane's in a hurry. Alright. Now let's draw our good old right triangle. It's climbing at an angle of elevation, 11 degrees. We need to find this distance when it's gained an altitude of 400 feet. So this is the same exact one as last time. With respects to angle 11, the distance is adjacent, the altitude is the opposite side. So we're going to be using tangent again. Alright, so Gatoa. Alright, so tan 11 equals opposite over adjacent, which we call D. Now it's okay for the variable to be in the denominator. Sometimes students don't like that. It just requires a little extra work. Let me reorganize my work. D equals D times tan 11 equals 400. So when we get D times tan 11, remember tan 11 is just some number. Tan 11 is about 0.1943803091138. So we're just going to divide it. It's a number. It's just presented to us a little goofy, something we're not really familiar with. So to solve this, I'm just going to do 400 divided by tan 11. And it's going to give me 2,057.8 feet. So again, this is actually something useful. Airplanes taking off, they have to figure out how high they're going, what angle they're climbing at, the horizontal distance, the vertical distance. They don't want to run into any objects. They don't want to run into cell phone towers, buildings, so on and so forth, to make sure they have enough runway. So that's how you do this problem there. Alright, a wire attached to the top of the pole reaches a stake in the ground 20 feet from the foot of the pole and makes a 58-degree angle with the ground. Alright, so we got some pole. It's carrying the American flag. We'll be patriotic. Except I can't draw that good. It's American flag. Now there's a wire that's in a stake in the ground right there, 20 feet from the foot of the pole. So this is 20 feet. This is 58 degrees right here. Find the length of the wire. So we need this length right here. So with respects to 58, the wire length is always going to be, it's the hypotenuse, it's opposite the right angle, and then we have the adjacent side. So adjacent and hypotenuse, that's going to be cosine. So we haven't used cosine yet today. So I'm going to have cosine of 58 equals adjacent 20 over the length of the wire. W cosine 58, which is just some number, equals 20. I want to get W by itself, so I'm going to divide both sides by cosine 58. So W equals 20 divided by cosine 58, which is about 37.7. Okay. Cruising right along. From the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. So let's stop right there. Depression of 40 degrees, you're looking straight out and then down. Alright, that's the angle of depression. A lot of times people say, well, this is 40 degrees, that's the angle of depression. That's false. Alright, common mistake. Don't make that common mistake. If the tower is 40 feet in height, how far is the partner from the base of the tower to the nearest foot? All right. So there's a bunch of ways to do this problem. All right. Probably the easiest way, and the way that's going to take the least amount of explanation, is to say, well, since this is 40 degrees right here, this has to be 50 degrees. All right. Again, bunch of ways to do this. This is probably the easiest way because they make a right angle. These two angles are complementary. All right. So then with respects to 50, we have the opposite side, we have adjacent side. So I'm going to be using tangent. So tan 50, opposite is x, adjacent's 45, and then it just becomes a classical problem that we saw from here. X equals 45 tan 50, which is about 53.6. Cool beans. All right, we'll finish these notes in the last video.